this short video, we're going to talk about ionic compounds, what ionic compounds are, how to write their formula, and how to write the names of those compounds from the formula. So let's start off with what is an ionic compound. An ionic compound is a metal bonded to a nonmetal, but not just a metal and nonmetal, the ions of a metal and a nonmetal. So for aluminum oxide, we have down here, we have the aluminum ion, the positive 3 charge. This is a cation because it's positive, bonded to an oxygen which has a negative 2 charge, and that's the anion. But before we talk about anything else, I want you to pull out a periodic table because you need this information before you can do anything else. Pull out a periodic table, and there's one in the back of your chemistry problem and solutions book. There's one in the back of your laboratory manual, or you can also print one out online. So on the top of the first column, which is labeled 1A, I want you to write +1. On the top of the second group, which is labeled 2A, write +2. And 3A, which you skip all the transition metals, go over the column that has boron, and write +3. Okay. Now we're going to skip 4A and go to 5A. Write -3 over that group. 6A, write -2. And for 7A, write -1. So all of those elements, when they form an ion, form ions with fixed charges, and everything in that group that you wrote the charge over forms a ion with that charge. So everything in the first group, the one with hydrogen, leave hydrogen out. It's an exception to most rules. So lithium and below, lithium will form lithium +1, sodium will form sodium +1, and so on. So I need you to go ahead and write that on the periodic table. If you haven't done that yet, go ahead and pause the video because you're going to need this information before we can move forward. Okay, so I have an example written of the formula for an ionic compound. We have Al2O3, and this is written from the formula to the name of that formula, aluminum oxide. So, if we have the name aluminum oxide, and notice this is oxide even though this is oxygen, because when oxygen is in its ionic form, you drop the YGEN and it becomes oxide, so you're adding IDE. Same thing for bromine, so when it's in its elemental form, it is bromine, so it's Br on the periodic table. You drop the INE and it becomes bromide. And then you also have chlorine going to chloride for those monatomic elements or ions. So when we have the name, we can go ahead and write aluminum. Al is the symbol for aluminum, and we can write oxygen, which is O. But in order to write the formula, we have to know the charges that the metal and nonmetal will form. And when we look on the periodic table, we see that the aluminum is in group 3A, and it forms a +3 charge. So we write aluminum +3. Oxygen is in group 6A, and it forms a -2 charge. So to go from the name of the formula to the formula, we have to swap and drop. And the way we do that is we're going to be crossing the charges down. So this goes down and it becomes the subscript for oxygen, the 3, So the plus 3 goes on here. The charge on oxygen crosses down and becomes the subscript for the aluminum. So we just swapped, and we have to drop. And what we're dropping is the charges. So you can just remove those charges. You see that the number for oxygen is the number on the subscript of aluminum, and the number for aluminum, the charge on aluminum, is the subscript for the oxygen without the plus and the minus sign. And when I say subscript, I'm just talking about these numbers down here on the bottom, and those numbers represent the number of ions of each ion or element that's present. So if you look down here at my example, this means that there are 2 aluminum ions present for every 3 oxygen ions that are present. So it's a ratio of 2 to 3, 2 aluminums per every 3 oxygens that are present. And the reason for this is that you need 3 oxygens to cancel out the charges for 2 aluminums. So these prongs, this isn't what the ions actually look like, but the prongs represent the charges on each one of these elements or ions. So if we had just the aluminum, just one aluminum, we see that we need an oxygen and a half to cancel out the charge on the aluminum to make it neutral. And that's our goal when we're writing the formula for ionic compounds, to make it neutral. But we can't have half of an oxygen ion, so we have to keep adding another aluminum, so we add a second one, so that these charges will cancel. So if you look, there's 2 total aluminums, you can tell by the subscript up here, and the aluminums have a positive 3 charge, so 2 times 3, this is 6, sorry you probably can't see that, this is 6, that's a total positive charge in this, and we also have oxygen. There are 3, so the subscript, 3 oxygen ions with a negative 2 charge, so 3 times negative 2 is negative 6. So positive 6 plus negative 6 is equal to 0. This is awesome because we wanted to get the compound to have a neutral charge. So, the ions are bonding in order to be neutral. So, let's see. One thing I do want to note, we did do the swap and drop method, but that was when the charges were different, so we had a positive 3 here and a negative 2 here. But, like I said, those numbers are ratios of aluminum to oxygen. So if we have this example, see that aluminum is plus 3, but we also have, we're going to bond phosphorus instead of the oxygen to it. And when phosphorus forms an ion, it forms negative 3 if you look on your periodic table. But if you cross these down, red, and then you drop the charges, we have aluminum 3, phosphorus 3. Okay? But if it's a ratio that's saying aluminum, there's 3 aluminums per 3 phosphorus, or this is the same thing as saying 1 aluminum per 1 phosphorus. So it's kind of like reducing a fraction to the lowest term. You basically, if the charges are the same, you don't have to put any subscripts there because the ratio is 1 to 1. So this is not going to be correct. It's going to be aluminum, or ALP, no subscripts, if that compound actually forms. Okay, so the following is going to be some examples of how to take the formula and change it into the name of the compound, and we're also going to take the name of the formula and change it into the formula for that compound. So here are some examples of how to go from, so in the 1 and 2 we're going to go from the formulas and find the names of these, and in 3 and 4 we're going to go from the names and find the formulas of these. Now right now we're only dealing with cations or compounds who have cations that have fixed charges. And what do I mean by that? I mean that, for example, aluminum can only form an ion with a positive 3 charge. But if it doesn't have a fixed charge, like iron, for example, iron can form +2, but it can also be iron +3. Okay, but what we're dealing with right now, simplistic, we're not dealing with more than one oxidation state or more than one type of ion. So let's look at our first example. We have BaCN2. We name the cation first and the anion second. So we look in the periodic table. Our periodic table tells us that the symbol Ba is barium. And we know, because we have this polyatomic ion list memorized, that Cn is cyanide. So we're naming the anion second. So this formula, the name for this formula is barium cyanide. So these are all of the polyatomic ions that we have to know for the test. So we have one cation here, which is ammonium, NH4 plus +1 charge. The rest of these are anions. So pretty simple if we have our polyatomic ions list memorized. Let's go down to our second example. We have CaCrO4. We look in our periodic table and we see that Ca is our cation. We're naming that first. And then we see that Ca is calcium. And then, because we have our list of polyatomic ions memorized, we know that CrO4 is chromate. So we have calcium chromate. Pretty simple. Okay, example number 3, we're going from the name to the formula. We have sodium hydroxide. We have to look in the periodic table. We see that sodium is in group 1A, and sodium has a +1 charge, forms an ion with +1 charge. So we have our sodium +1. And we know our hydroxide, because we have this list memorized, is OH minus. So we have +1 and -1. Those charges are the same. So you can cross them down if you really want to, if it helps you. But that's just going to be NaOH. We put the cation first and the anion second. Fourth example, silver phosphate. We look on the periodic table and see silver. The symbol for silver is Ag. And this you don't know yet, I guess. But silver does have a fixed charge. It can only form silver +1. And then we look on our polyatomic ion list and we see that phosphate, formula for phosphate, is PO4 -3. This time we do cross our charges down. So we're going to swap and drop. The charge on the silver becomes the subscript for the phosphate ion, and charge on the phosphate ion becomes the subscript for the silver. When we swapped, we have to drop. What we're dropping is the plus and minus sign, so that's just 1, and then that is just 3. So when we write our formula, it is silver 3 phosphate. And in our next video, we're going to talk about compounds with ions, or the cations, that have more than one oxidation state or more than one charge.